Hello, everybody. Welcome to week 4 of our webinar. This week, we will be looking at steps 3 and 4, univariate analysis and bivariate analysis. I'm William O'Bannon of StatsWhisperer. All right, now, as always, we always like to keep in mind where we are in our 6-step process of data analysis. And this week we are on steps 3 and 4. So for both processes, we are creating profiles, and then we are holding our first round of analysis. So in the dating analysis, right, you would have a profile of a dater, right, one person, right? So if this is our dater and that's their profile on eHarmony, that you would describe the characteristics of that one dater, right? Gender, female, age 32. Now reflexively, if we were talking about data analysis, we're making a profile describing each variable, right? So we have a couple of examples here. So if we had a sample of 100 people, right, and we have a variable called gender, we would want to describe the characteristics of the variable gender, as if it were a person we were talking about, right? So we say of the variable gender, what are the characteristics? 70% of the sample is female, and 30% is male, right? And then also, if we were looking at the variable age, we would want to describe the characteristics of the variable age, right? So the characteristics are the average age or the mean age, the same thing, is 32 years, and the standard deviation is 11.0. So this is just a quick little review before we get into it deeper. So this is not the only presentation I'm going to make on this. All right. So also in step 4, we have our first round of analysis. Right. So in the dating analysis, you might have the central person, right? The central person who's dating. Could be you, could be anybody, right? And suppose you have 4 people that answer the profile. So you have 4 people to choose from. What do you need to do, right? You need to figure out just who you have a significant relationship with one-on-one, right? So in our example here, we have like the Manny Bills monthly, and then the central dater is Connie. So do they have a significant relationship? Does education level have a significant relationship, right? So you see on the lines, there's a little sig with a question mark for each, saying, is this a significant relationship, right? So you're relating the 4 to the central one, and that's quite like our data analysis, right? So the same thing, except we have a dependent variable, which is our construct of interest, and that's happiness. So we're saying which of the independent variables one-on-one has a significant relationship with our dependent variable. Does having many bills monthly have a significant relationship with happiness? Does your education level have a significant relationship with happiness, right? Does your level of humor have a significant relationship with happiness, right? So what we're wondering is on a one-on-one relationship or a significant impact, you might say, on one's level of happiness. So step 3, creating the variable profiles. Now, if we were going to speak scientifically, we might call this step univariate analysis. Some people call it descriptive analysis because you're describing the variables. I like to call it univariate analysis because it fits in with the scheme of univariate, bivariate, and multivariate. Right? So uni meaning one, var meaning variable. So univar, right? Univariate analysis, the analysis of one variable. In other words, the analysis is presenting the characteristics of one variable. So, univariate analysis, very easy to do in SPSS. We'll go through it right now. We follow the chain analyze, descriptive statistics, frequencies. We put our variables in the column on the right. Under statistics, we're going to click mean of standard deviation, then OK. Right, so let's go and do that in SPSS right now. So as I said, here's our happiness database. So we click Analyze, Descriptive Statistics, okay. Then Frequencies, and then they're all in here already. Let me put them back over there. So then we scroll down to see our variables, and then we see them right here. Many bills monthly, that goes to the right. Education level, humor, aloofness, and then happiness. There's a little CONT continuous, so it's just happiness on a continuous scale. Then under statistics, we click that, and then over the upper right, we click mean. In the lower left, we click standard deviation, then continue, and then OK. So then we get our frequencies, right? Frequencies. The first box is the statistics box. That tells you the valid responses. We have 50 people. Up top, all 50 people gave valid responses, and missing 0, 0, 0. So they're all there. And then the mean, for the categorical variables, it's not that meaningful, right? So because they're categories, right? So it's more meaningful for the continuous variables. So we see the mean for humor is 3.68. If you recall from last week, the scale is 1 to 5, right? That makes the mean meaningful. If it's a mean of 3.68 on a scale of 1 to 10, it's different than a mean of 3.68 on a scale of 1 to 5. So you have to keep in mind the scales when you interpret the mean. So 3.68 in the standard deviation, 1.09, the mean 3.82 for aloofness, 3.18 or 19 if we round it up for happiness, right? And then down here, we have the frequency tables that shows a dispersion. So for many bills monthly, yes. 20 people, yes, have many bills monthly, which is 40%. 30 people, no, which is 60% do not, right? So education level, we have 19 people in high school, which is 38% of the sample. 16 people, which is 32% of the sample in college. And 15 people, which is 30% of the sample in whose highest level of education is graduate school. And then down here is just the dispersion of cases of scores, rather, for the other variables, like humor, right? So the lowest score is 2, the highest score is 5 on that 1 to 5 scale. Aloofness, the lowest score is 2, the highest score is 5. And for happiness, the lowest score is 2, and the highest score is 4.20. Now if we go back to our slides, we can see how we might want to present those. This is just about APA format here. So in the you make two separate tables. One for the continuous variables right here, where we have the variable, right? Then the mean, then the min-max, which is the highest and lowest scores. And then you always want to say the scale, possible scale range. So when people interpret it, if they don't know the scale range, that they could see it right there. So if happiness is a mean of 3.19, they'll know that it's on a scale of 1 to 1.0 to 5.0, so it's somewhere close to the middle, right? And that's different if it was a scale of 1 to 10, where 3.19 would be in the lower third. right? So these are the good values to present for our continuous variables. Now our categorical variables, right? We would like to present the n, which is the number in each category, and the percentage, right? So it's a little less, right? So as we said, we have our number in high school and the percentage, right? The same for college and graduate school. And then for many bills monthly, we also present, right? Yes, how many people have many bills monthly, and no. So yes is 20, which is 40%, and no is 30, which is 60%, which is also what we went over in the output, right? So these are how the profiles of the variables are presented, and these are the critical values to present for the categorical and continuous variables, so people can get a good grasp of what these variables are and what they're. Right now, we move on to step 4, right? So that was step 3. Pardon me. So there's a little more involved in step 4 relative to step 3, but it's perfectly manageable. Step 4 is our first round of analysis, right? Or in other words, our bivariate analysis round. Bi meaning 2, variable, var meaning variable, right? So bivariate analysis, the analysis of 2 variables. Specifically, we're doing an analysis that says on a one-on-one basis, one-on-one, 2 variables, is there a significant relationship between the 2 variables? So one-on-one tests define significant relationships. Now we'll be using 4 tests to identify these significant relationships, right? The t-test, the chi-square, the ANOVA, and the correlation. These are our 4 tools to determine these relationships. Choosing the correct bivariate test depends on the structure of the variables. So you must look at the variable structure in order to determine which is the right bivariate test to test the one-on-one relationship. So you must consider 3 variable structures. Right? So when I say look at the structure of the variables, what does that mean? It means you have to categorize the structure as one of these 3. Either it's a continuous variable, right, where it can, like humor, it's continuous, measured from 1 to 5, right, with 5 meaning more humor, right, a continuous scale. Categorical with 2 categories, like our many bills monthly has 2 categories, yes and no. And lastly, categorical with 3 or more categories, right? So we went over this before, but you can never go over the basics too many times, right? 3 or more categories: education, having high school, college, or other. So here's our bivariate test key. So this will tell us which bivariate test to use according to the structure of the variables. So if it's categorical with 2 categories, and continuous, it's a t-test. Categorical with more than 2 categories and continuous, it's an ANOVA. 2 continuous variables, you use a correlation, and 2 categorical variables, you use a chi-square. And if you apply this key, you could do your bivariate analysis with any variables you need. So, in the interest of our study, we will plug in our variables into the bivariate test key table. So remember, we have one dependent variable, which is happiness. It's continuous. We have 4 independent variables, and we're wondering what the relationship of each independent variable is with the dependent variable. So sometimes, to keep things as neat as possible, you might want to put the dependent variable in one column, right? So we have our A and B column. So I put the dependent variable in the B column. Pardon me, and all the independent variables in the A column. So you can see all the way down the B column is just our continuous variable happiness, and all the independent variables one by one are in column A being compared with that. For example, the first relationship we're looking at is categorical with two categories, which is many bills monthly, and our continuous happiness dependent variable, and you would use a t-test. Right? And then the next one we have categorical with more than two categories, which is education, and high school, college, and graduate school, being related to happiness, continuous variable, ANOVA. Then we have our two continuous variables, humor and happiness, a correlation, and also our continuous variable, aloofness, and happiness, continuous, a correlation also. So now we have our map here of how we're going to test all our bivariate relationships, all our one-on-one relationships, right? So we have 4 separate one-on-one relationships, and we're going to do 4 separate tests, one to look at each of them. You'll notice we didn't have a categorical and categorical variable, so that we didn't have an opportunity to do our chi-square. So we'll just do an example of a chi-square using categorical variables, many bills monthly, and education, just so we run through the procedure. So the first test, right, our t-test, that's the first one we said we needed to do. Right, so a t-test tells us if there's if significant differences exist in mean scores, on mean scores, or in mean scores, right? So the mean scores, right, that you think continuous, right? The mean score is a continuous variable, so the mean scores of happiness, right, by a categorical variable with 2 categories, which is for us is going to be many bills monthly. So the t-test and SPSS, first you need to go to Analyze, Compare Means, Independent Sample t-test. Then we're going to specify our grouping variable, which is our categorical variable, our test variable, which is our continuous variable, and click OK. So let's do that right now. So Analyze, Compare Means, and Independent Samples t-test. Okay? And then we're going to look for our grouping variable, which is many bills monthly, right here. Put it in there. Then it'll say, please define. So you say 1 means yes, and 0 means no. And then we put in our happiness, continuous happiness dependent variable. And then we're all set up to do our test. We click OK. And there's the t-test output. This is also in our slides. I'll go over that, but to look very quickly here, this is the output for our t-test, group statistics and independent samples. Now, let's look at our slides. So there's the t-test output we just looked at. So the first thing you want to look at on the output is the significance level, right? Is it a significant relationship? That's our big question. If the relationship is not significant, we don't need to look at any other part of it, right? If it's not significant, we don't consider it. How do we know if it's significant? If it's less than 0.05, and we see here, it is less than 0.05, right? So the sig is highlighted, and the significance is 0.000. So we know there's a significant relationship. So then we say, well, just who's significantly higher and who's significantly lower in terms of the mean score. So we go up here, and we see, do you have many bills monthly? Yes. So these are the people that do have many bills monthly. And their mean score of happiness is right here, 2.74. And do you have many bills monthly? No, their mean score of happiness is 3.49. So there's a significant relationship where the happiness score for people that don't have many bills monthly is significantly higher than those that do. So we can see that right here. The t-test results equal there's a significant difference in the mean scores of happiness. Specifically, those with many bills monthly have a significantly lower score of happiness than those without many bills monthly. And then we can enter that in our map right here, like our outline. So you'll notice here we've gotten rid of the sig with the question mark here, and we put on the relationship line, the t-test says there's a significant relationship here between many bills monthly and happiness. Right? So that's the first part of our puzzle filled in. Now remember, number 2, we said we need to do an ANOVA. Right? The ANOVA will tell us if there's a significant differences in means exist on mean scores, right? Mean meaning a continuous variable, happiness for us, for a variable with more than 2 categories. So a t-test is for 2 categories, right? For more than 2 categories, you need to use an ANOVA. So we'll be using education as our variable with more than 2 categories. So it's a little longer list here of things to do. So analyze, compare means one-way ANOVA. Right? The factor variable is going to be our categorical variable. Education, our dependent list, will be happiness, the continuous variable. You have to remember, under the post hoc option, to click Bonferroni, then continue. And under options, click descriptive and continue. Then click OK. And then you have your ANOVA. Let's do that. So analyze, compare means, one-way ANOVA. So there we go. So we want to go down here. We want to put happiness, right, like I said, in the dependent list, or continuous variable. And in the factor list, we want our categorical variable with more than 2 categories, education. Then as I said, you must go to post hoc, click it, and then click Bonferroni in the upper left, continue. Then under options, click descriptive and continue. Then you're all set. So then we click OK. We get more output, right? So one way, that's where it starts, ANOVA. So here's our output. We get our descriptive table that tells you the mean of happiness for each category in the categorical variable. And it tells you if the test was significant, right here, 0.000, which it is. And then the Bonferroni, see the t-test, there's 2 means. So if there's a significant difference, it's between the 2 means. For the ANOVA, there's more than 2. So here there's 3. So if the test is significant, it says there's a significant difference in the means, but then is it mean 1 compared to mean 2, or mean 2 compared to mean 3, or 1 compared to 3? Just where is the significant difference between the means, right? That is indicated by the post hoc test, right? So it'll say significant right here. That means significant difference in the means. Then the post hoc test will tell you just between which means are significantly different. So we will go to the slides for this as I put these in there. So here we go. There we go. So the first part that we showed was that the ANOVA, the first thing we look at for the ANOVA is that second box, is it significant? So 0.00, yes, the ANOVA is statistically significant. And then we want to look at the means and say, well, who has the highest and lowest score, right? Is there a trend in the means? And you can see high school, the mean level of happiness is 2.58. In college, the mean level of happiness is 3.16. And in graduate school, the mean level of happiness is 3.99. So it looks like there's a trend where the higher the education, high school, college, graduate school, the higher the mean score of happiness, 2.58, 3.16, 3.99. But still, we don't know, is 3.16, significantly higher than 2.58. Is 3.99 significantly higher than 2.58? We don't know. We need to look at the next table, which are the post hoc tests. Right? So what I said was, right, so high school is the first category, and then it says in reference to college and graduate school right here. So the little asterisk here, right, it says the mean difference is significant at the 0.05 level, meaning it's statistically significant for us. And you can also see the 0.00s indicating that same thing. So it'll say high school in reference to high school, in reference to college, right? The high school scores are negative, right? So it's lower, 0.58 lower, right? So high school, on average, the score is 0.58 less than college. High school, on average, is 1.41 less than graduate school, right? So you can see all the differences are statistically significant here. And then we see for college, right, our second category, college, in reference to high school, they're 0.58 higher, right, the same as the first finding. And then for graduate school, college, in reference to graduate school, is 0.83 lower. These are all reflexive. And then graduate school, right, in reference to high school, is 1.41 higher. College, graduate school in reference to college is 0.84 higher, right? So they're higher than everyone else. High school is lower than everyone else, and college is significantly higher than high school, but significantly lower than graduate school, right? So that's the results of our ANOVA. So then we can take the results of our ANOVA and again put them right in our relationship line, saying there's a statistically significant relationship between education level and happiness. And so we're filling in the puzzle as we go. Now, our next test is going to be the correlation. Correlation is used when you have two continuous variables and you want to see if they're correlated at a significant level. So correlate, what does that mean? That means either as one variable increases, the other increases at a significant rate, right? So if your level of humor increases, does your level of happiness also increase with it at a significant rate? So as humor goes up, your level of happiness goes up. Or they could decrease. It could be a negative relationship where it could be aloofness, right? So as your level of happiness goes up, right, your level of aloofness goes down, right? There's a negative relationship. So the more happiness, the less aloofness. But the more humor, the more happiness, right? Let's illustrate this in statistics. It'll be easier to see. So in SPSS, to do a correlation, you go to Analyze, Correlate, and Bivariate. Then you enter your continuous variables in the right-hand column titled Variables and click OK. So correlate, right? So analyze and then correlate, then bivariate, right? And then we find our bivariate, our continuous variables. So first I put in our dependent variable, happiness, and I put in humor and aloofness. Right? So there we go. That's all we need. Click OK, and then we have our correlation table. So this is also in the slides, but to start off, so you see just what we really want is that first level. So it's happiness. Refer to happiness is perfectly correlated at 1. Remember, correlations can go from 0 to 1. 0 meaning no correlation, 1 meaning perfect correlation. Right? And then we have humor and aloofness. So let's go to our slides. And there we go. There's the correlation table we just looked at, just enlarged a little bit. So we have happiness, And then happiness, when it intersects with humor, has a correlation of 0.57 via 2 asterisks, meaning correlation is significant at the 0.01 level, which is below 0.05, so it's significant. And we also see there's no minus here before the 0.57. So the no minus means it's a positive relationship, as in as happiness goes up, humor goes up at a statistically significant level, right? And we see the value is 0.000, which is far less than 0.05. And then for aloofness, we see that there's also a significant correlation, right? 0.009, less than 0.05, and our 2 asterisks. But there's a negative sign here, meaning a negative relationship. So as happiness goes up, aloofness goes down at a statistically significant level. So there we have it. We have all our one-on-one tests done, right? So we see that there's actually a statistically significant one-on-one relationship for each independent variable with our dependent variable. Many bills monthly is significantly related to happiness. Education is significantly related to happiness. Humor is significantly related to happiness. And aloofness is significantly related to happiness, right? So we've answered our big question. Now, we're also going to do our chi-square to see if the proportion within the chi-square to see if the proportion within categories differs significantly for 2 categorical variables. Okay? So let's apply a research question to this since it differs from the rest of our analysis, which looked at our dependent variable happiness. So let's say we wanted to find out, does having many bills monthly differ at a statistically significant level by your level of education? So if you have a differential level of education, high school, college, graduate school, are you more or less likely to have many bills monthly? So the chi-square and SPSS, there's a couple of ways to do it, but this is one of them. Analyze descriptive statistics in crosstabs. Then we're going to enter one variable in the column, one in the row. I like to put the dependent variable in the column. Then under the statistics, we click chi-square and continue. Under the cells, we're going to click, under percentages, we'll click rows and continue, and then we click OK. So let's do that now. Analyze, descriptive statistics, and then crosstabs. And then, as I said, we will find our categorical variable, education level. Right? Let's put that in the column. And let's take the many bills monthly and put that in the row. As a matter of fact, let's reverse that. Sometimes it's neater to have the 2 categories in the column. There we go. So then under statistics, we click chi-square, continue. Under the cells, right, under percentages, we'll click row percentage, continue, and then we click OK. And then see crosstabs where it begins. This is our chi-square. So the first box just tells us, everybody that was included, the N, which is 50. So everybody was included. There's N of 0 missing, so that's great. So the total used is 50. Then we have our actual crosstab table here that tells us the breakdown. And then the third box tells us the significance level. What we care about is that first line, Pearson chi-square, and this significance level right here. So we see it's significant, a statistically significant difference in the proportions. Now let's go to our slides and look at the chi-square. Right? So this is the same thing that was on the output, just made a little bigger, so it's easier to interpret. Right? So On the left, we have education level, high school, college, and graduate school, right? Then that's cross-tabulated, right? Cross-stratified by the many bills monthly, yes or no, right? So the first thing we want to look at, as we said, is the significance level, which is in the third box, the first row. It's 0.027, which is below 0.05, saying it's a statistically significant difference, right? Then we might want to just look in one column at the percentages by education level. So the people that have many bills monthly, so people at the high school level who have many bills monthly, it's 63.2%, right? So that's what we're looking at. So in high school, what percentage have many bills, don't have many bills monthly? 36.8, right, which is 7 people. How many do? 12 people, which is 63.2, and that's 100%, and that's 19 people. So that's how those 19 people are distributed by those two categories. So about 2/3 of the people in high school, at the high school is their highest level of education, have many bills monthly. So when we go to the college level, what percentage have many bills monthly? 31.2%, which is 5 people, right? So it's 16 people. 5 of them have many bills monthly, 11 don't, so it's 31.2%. So at the graduate school level, right, we look and we see that only 20%, right, or it's 15 people, 3 have many bills monthly and 12 do not. 20% have many bills monthly. So we see as education increases, high school, college, graduate school, the percentage within each category that have many bills monthly decrease, going from 63.2 to 31.2 to 20%, right? So we would say that there's a significant difference, right? There's a significant difference where the more education you have, significantly lower proportion of people have many bills monthly. Do a chi-square. Now, let's take our results, right? We take our results. So we found that all our independent variables had a significant one-on-one relationship with our dependent variable. But you cannot tell at this level which independent variable has the strongest relationship with the dependent variable. You could say they're all related, but you can't say which one has that strongest relationship with happiness, right? Which, yeah, is perplexing, right? So in step 5, the final analysis round, that's what we'll be able to determine. We'll be able to say in step 4, we identified that all these variables had a significant one-on-one relationship with happiness, right? But we can't say which really impacts happiness more than anything else. This is a really, really important point that I'll repeat. So, pardon me. So in the final analysis round, right, we'll be able to consider all 4 independent variables and say which one really impacts happiness, which one has that strongest impact on happiness. Right? And don't forget, if any of those independent variables did not have a significant relationship with happiness, right, our dependent variable, it would be left in step 4 and not carried forward into step 5. However, here, all of them had a significant relationship. So all 4 independent variables are carried into step 5. And then next week in step 5, we'll determine the strongest independent-dependent variable relationship of all these variables that had a significant relationship in step 4, the bivariate relationships. Right? So if we look at if this was dating again, the poor dater, she would find out that she had a significant relationship with each of these potential suitors. Each of these 4 suitors, she realizes, I have a significant relationship with all 4, but I need to identify which one, right? I have the strongest relationship with, so she can go out on a date, right? So that's going to be for her for step 5 also, right? And again, right, so which is it? All the independent variables are significant, but what one variable impacts happiness beyond all else? Again, we can't see it at this step, right? We can only see that everything's related. We can't see which is related more than anything else, but we will be able to find it in step 5. And that is the end. I will talk to you in our next webinar.